In elementary school, using hands-on manipulatives can really help kids learn. For this demonstration, there will be two tasks. The first task will focus on perimeter, while the second task focuses on algebraic expressions and multiplication. In third grade, kids can use blocks to help them develop algebraic thinking by finding perimeter through growing patterns. The Common Core standards for third grade states, solve real-world and mathematical problems involving perimeter polygons, including finding perimeter given side lengths, finding an unknown side length, and exhibiting rectangles with the same perimeter in different areas or the same area in different perimeters. Using pattern blocks is a great way to introduce perimeter in geometric measurements. Perimeter is the distance of the outside of a two-dimensional shape. For this activity, students are tasked with finding the perimeter of a caterpillar on its third birthday. Before having students do this, it's important to model the perimeter of the caterpillar on its first birthday. On its first birthday, the caterpillar consists of a triangle and a square. After its first birthday, we'll be adding a rhombus and a square each time. And to find the perimeter, we have to count up the sum of the side lengths. So 1, 2, 3, 4, 5. And on its first birthday, the caterpillar has a perimeter of 5. On its second birthday, we'll add a rhombus. And to find the perimeter, we have to count up the sides again. So 1, 2, 3, 4, 5, 6, 7. And on its third birthday, we'll add another square. 1, 2, 3, 4, 5, 6, 7, 8, 9. So on its third birthday, the caterpillar has a perimeter of 9. And so students must figure out what the pattern is. And the pattern is that each time you add a square and a rhombus, the perimeter grows by 2. So with each birthday, we're continuing to add 2. So that's a great example of how you can use pattern blocks to show algebraic reasoning. So for the second task, we'll focus on algebraic expressions and multiplication. You can also use blocks to demonstrate forming shapes. You can put smaller shapes such as 2 trapezoids to form 1 hexagon, or break down a hexagon into 2 trapezoids. The Common Core standards for this task is use multiplication and division within 100 to solve word problems in situations involving equal groups, arrays, and measurement quantities. Another standard states identify arithmetic patterns, including patterns in the addition table or multiplication table, and explain them using properties of operations. So as you can see here in this handout, students must design a walkway made of hexagons. Before the walkway is finished, you've run out of hexagons, so you have to use other shapes such as trapezoids, rhombi, or triangles. And so when students look here, they see that X represents the number of hexagons. So the hexagons that are in the walkway, if there's 1 hexagon, kids have to figure out the number of trapezoids it would take. So you could see here that here's 1 hexagon, and then you have to figure out how many trapezoids would it take to create 1 hexagon. And so you can see here that it takes 2 trapezoids to create 1 hexagon. So then the number of trapezoids would be 2. And then for 2 hexagons, it would take 4 trapezoids. And so for 3 hexagons, it would take 6 trapezoids. So each time you're adding 2. And so 4 hexagons, it would take 8 trapezoids. And so then you have X, and since X represents a number of hexagons, so if the pattern is 1, 2, 3, 4, you know the next number of hexagons would be 5. So if you have 5 hexagons, and you know each time it's going up by 2, then the algebraic expression that you could write to find the number of trapezoids for 5 hexagons would be 2 times 5 equals 10, and the algebraic expression would be 2x equals 10. And that would equal the number of trapezoids, since x equals represents the number of hexagons. And so this is just a great way to show algebraic reasoning through patterns.